5 billion years from now, the Sun will be unrecognizable. It will have swollen to over 200 times its current size, so large it will swallow Mercury, then Venus, and possibly Earth itself. Its surface will have cooled from blazing white to a deep smoldering red. It will be a red giant. In our last video, we watched stars being born, igniting from cold clouds of gas into brilliant, burning suns. But nothing lasts forever, not even stars. Today we're following our Sun, and stars like it, through old age, transformation, and a surprisingly quiet death. And along the way, we'll answer one of the most personal questions in astronomy. What happens to Earth when the Sun dies? Right now, our Sun is in what astronomers call the main sequence, the long, stable phase of a star's life where it burns hydrogen in its core. It's been doing this for about 4-6 billion years, and it has roughly another 5 billion years to go. During this phase, the Sun is in perfect balance, gravity pulling inward, fusion energy pushing outward. A tug-of-war that has been going on since before Earth existed. But hydrogen is not an infinite resource. Slowly, over billions of years, the core runs out of fuel, and when that happens, everything changes. Here's what happens when a star like our Sun exhausts the hydrogen in its core. First, the core, no longer producing fusion energy, begins to contract under gravity. It gets smaller, denser, and much hotter. That extra heat spreads outward and ignites a shell of hydrogen surrounding the core. Fusion moves from the center to a ring around it, and that extra energy has nowhere to go but outward. The outer layers of the star begin to expand, slowly at first, then dramatically. Over millions of years, the star balloons outward. Its surface cools as it stretches. The color shifts from yellow-white to orange, then to deep red. The star has become a red giant. When our Sun becomes a red giant in about 5 billion years, the inner solar system will be transformed beyond recognition. Mercury will be consumed first, vaporized by the expanding star. Venus will follow. Earth's fate is less certain. Some models suggest Earth's orbit will shift outward as the Sun loses mass. Others suggest the Sun's expanded outer layers will drag Earth inward and swallow it. Either way, long before the Sun physically reaches Earth, our planet will be uninhabitable. The oceans will boil away. The atmosphere will be stripped. The surface will be scorched bare. While the outer layers expand, something dramatic is building in the core. As hydrogen fusion happens in the shell around it, the core fills up with helium, the ash left over from burning hydrogen. The helium core keeps contracting and heating, until, at around 100 million degrees Celsius, something explosive happens. The helium ignites all at once, in an event called the helium flash. In just a few minutes, the core releases as much energy as the Sun normally produces in millions of years. It's one of the most violent events in a star's life. But here's the strange part. We can't see it from the outside. All that energy is absorbed by the star's outer layers. The helium flash is a secret explosion, hidden deep inside. After the flash, the star stabilizes briefly, burning helium in the core. It shrinks slightly, burns a little bluer, but helium is depleted even faster than hydrogen. The second fuel supply doesn't last long. And when it runs out, the star enters its final chapter. With its helium exhausted, the red giant becomes unstable. Its outer layers, the vast, diffuse envelope of gas that expanded over millions of years, begin to drift away into space. Slowly, gently, the star sheds its outer skin. These expelled shells of gas form what's called a planetary nebula, one of the most beautiful structures in the universe. Glowing rings and clouds of pink, blue, and purple, lit up by the hot core of the dying star at the center. The name planetary nebula is actually a historical mistake. Early astronomers thought they looked like planets through their telescopes. They don't have anything to do with planets, but the name stuck. When the outer layers have drifted away, what remains at the center is the exposed core of the old star. This is the white dwarf. A white dwarf is extraordinary. It contains roughly the same mass as our Sun, but compressed into a sphere about the size of Earth. To put that in perspective, a teaspoon of white dwarf material would weigh about 5 tons on Earth. A white dwarf produces no new energy through fusion. It simply radiates the heat it already has, slowly cooling over billions of years, like a dying ember. Over trillions of years, far longer than the current age of the universe, a white dwarf cools and fades. Eventually, in the unimaginably distant future, it becomes a black dwarf. a cold, dark, inert lump of carbon floating silently in space. A tombstone for a star. But not all white dwarfs go quietly. If a white dwarf has a companion star nearby, it can slowly steal material from it, growing in mass. If it grows massive enough, it can trigger a catastrophic explosion called a Type Ia supernova, one of the brightest events in the universe. We'll cover supernovas in depth in our next video. But for now, remember, even in death, stars can go out with a bang. Stars like our sun don't explode. They don't go out in a blaze of glory. They expand, they glow, they shed their outer layers in breathtaking rings of color, and then they quietly dim, cooling for eternity. It's a slower kind of ending, but in its own way, it's just as profound. The material shed by dying stars, the carbon, oxygen, and nitrogen blown off in planetary nebulae, drifts through space and eventually becomes part of new nebulae. New stars, new planets, new life. The atoms in your body have been through this cycle before. They were forged in stars, scattered by dying stars, gathered into new ones, and eventually made their way into you. In the next video, we'll look at a very different kind of stellar death, the violent, explosive end of massive stars, supernovas. If you enjoyed this video, a like goes a long way. It helps more people find the channel. Subscribe if you haven't already, and let me know in the comments. Did you know the sun would become a red giant someday? See you in the next one. Keep looking up.